vehicle of this sort is no small feat, and we are super excited to be a part of the Roadster's billion-year journey through the solar system.
As Lauren just mentioned, if all goes well today, Falcon Heavy will put the Roadster on board into an Earth-Mars orbit around the Sun on a journey that could last for 1 billion years. Now, on a universal scale, this means that the Roadster will be tracing the shape of an ellipse with the Sun at one of its fixed points, or one of its foci. Now, we call this heliocentric because it is Sun-centered. The outermost distance on that same ellipse will intersect the path that Mars takes while it is on its own journey around the Sun. That's quite far away. That will reach a maximum distance from Earth of over 400 million kilometers. In Earth terms, that's about the same as a trip around the equator 10,000 times. Now, during its journey, the Roadster will also reach a maximum velocity of nearly 40,000 kilometers per hour, or about 20 times faster than a speeding bullet. Now, as we said, it should stay up in orbit around the Sun for about 1 billion years, and it's a very long, exciting road ahead, and we are thrilled to be able to take the first steps on that journey just 5 minutes from now.
The SpaceX team continues to count down for launch of Falcon Heavy test flight. Now, once we light the engines, Falcon Heavy will check the power on all 27 Merlin engines, a critical period in the go-no-go for launch. It will then command release from the ground hold downs. 40 seconds into flight, we'll decrease power on the 2 side boosters in preparation for maximum aerodynamic loads on the vehicle. Once we get through this period, Falcon Heavy will throttle back up to full power on the side boosters. About half a minute later, we will again throttle down the 2 side boosters. This time we're decreasing the forces on the rocket structure. At this point in flight, the vehicle is much lighter, having burned off much of the propellant, but we are increasing thrust. 2.5 minutes into flight, we'll fully turn off the side boosters, an event called BECO, Booster Engine Cutoff. At this point, the pneumatic separation system on the center core will unlock the 2 side boosters and push them away. The side boosters will disconnect first at the top of the center core, then milliseconds later from the bottom, so they'll actually rotate away from the center core slightly. Once the side boosters are clear, the center core will throttle up to full power and burn for another 25 seconds. Finally, at just past 3 minutes after liftoff, the center core will shut down, an event called MECO, Main Engine Cutoff, and the second stage will separate. From this point on, it's like a Falcon 9 mission. The fairing will separate, the MVAC-D upper stage engine fires, eventually sending the stage and payload out into the solar system to orbit around the Sun. So that gives you a feel for the sequence of events we're planning on today's flight. So now, at T-minus 4 minutes 45 seconds and counting, let's witness the test flight of Falcon Heavy.
MVAC and A1D fuel bleed has started.
Safety critical
lock slow, throttling to close up. NY lock slide complete. PY lock slide, throttling to close up. PY lock slide complete.
Stage 2 TVC motion's nominal.
BOGO bleed verification. Center core lock slide complete.
Strombeck lower has ended. Strombeck's at 88.2 degrees.
Stage 2 lock slide complete. Falcon Heavy prop load is complete. Falcon Heavy is on internal power. Vehicles in self-align.
Ground gas closeouts has started.
Falcon Heavy gas loads are complete. M1D fuel bleed complete. M1D engine chill is complete.
AFTS is ready for launch.
Ground gas closeouts are complete.
Falcon Heavy is in startup. Stage 2 pressing for flight.
T-minus 30 seconds.
Launch director on countdown 1. SpaceX Falcon Heavy, go for launch.
Falcon Heavy is configured for flight.
T-minus 15, standby for terminal count. 10, 9, 8,
Side booster ignition.
6, 5, 4, 3, 2, 0. Ignition.
If you can hear me over the cheering, Falcon Heavy heading to space on our test flight. Building on the history of Saturn V Apollo, returning pad 39A to interplanetary mission. We're getting ready to throttle down for max Q.
Supersonic.
You've heard the call out. Vehicle is supersonic. Side boosters are now throttling back up to full
Vehicle
power.
has reached maximum dynamic pressure.
We're past max Q, the period of maximum loads on the vehicle. Next up, we'll be waiting for the side boosters to begin to throttle down prior to booster engine cutoff and separation 2.5 minutes into flight. GNC trajectory looks good on the Falcon Heavy. Reports show that the M1D engine performance is nominal.
Contact engine sales begun.
Side boosters have begun to throttle down in preparation for the upcoming shutdown in 20 seconds. Major event coming up with side booster shutdown and separation.
Inside shutdown. Side boosters. Beaker. Center. We're southing up. S1 keeps going. Still booster boost box starting.
Successful separation. We're coming up on Miko in shutdown.
Stay set. Separation confirmed. Event recognition. This big burn looks good on side boosters. Backburn startup.
Coming up on fairing separation.
Center core side engines on fire, also look good.
Stage 2 is followed from that separation confirmed.
He's moving to recover now. Booster boost back shutdown. Center core boost back burn shutdown. Can you get acquisition of signal?
Wow. Wow. Did you guys see that? That was awesome. That's the only thing I can really say right now.
Absolutely wild. Absolutely wild. I got nothing else.
Oh, man. Recapping all the great things that you just saw there. Successful liftoff from the pad, successful stage separation, but before that, successful booster separation. You can see stage 1. The two side boosters, pardon me, you can see the center core, and you can see MVAC lit up. Oh my gosh.
Then the beautiful shots of Starman chilling in the Tesla Roadster. Just absolutely incredible. On your screen at the moment, you've got a few things happening. On the upper right, you've got MVAC D continuing its burn. On the upper left, you have the center core headed back towards the autonomous spaceport drone ship. And in the two bottom screens, you've got the side boosters headed back towards Cape Canaveral Air Force Station, landing zones 1 and 2. The next step coming up for the side boosters and the center booster is the re-entry burn. That's going to slow it down from, or slow all the boosters down from way faster than the speed of sound to just faster than the speed of sound in order to reduce some of those aerodynamic forces and heating that occurs when you're moving that quickly through the atmosphere.
And as you can see on your screen, that re-entry burn for those two side boosters has begun.
Side boosters entry burn shut down.
Side core entry burn started.
The center core in the upper left of your screen performing its own re-entry burn. You can see the edge of Cape Canaveral in both of the side booster cameras as those are coming in.
Yes, PY and NY side boosters have saved.
Center core entry burn shutdown.
And even though those look very similar, those two boosters views, those are actually representing different boosters. And they're heading towards Earth. They're about to begin their landing burns. We'll hopefully be able to bring you nice footage of that.
Both side boosters transonic.
And watch for the landing legs deploy at the tail end of that landing burn.
And that landing burn has started.
Both boosters looking to be on track towards their respective landing
Boosters
zones.
landing legs have started. Side boosters landing legs have deployed.
And the Falcons have landed.
LZ1, LZ2, both side boosters have touchdown. Landing off the move on to recovery 1 and recovery 2.
And coming up very shortly, the Center Core will be attempting its landing on the autonomous spaceport drone ship.
You may also be hearing the second engine cut off. Oh, check on your screen. Sometimes this footage goes out when it approaches the drone ship and the heavy vibrations make it lose signal. We're crossing our fingers that's not the case right now.
Stage 2, nominal parking orbit insertion.
So it looks like that landing is happening at the moment. We have lost signal. We're hoping that signal comes back shortly.
Oh man, yeah. As Michael mentioned earlier, with the vibrations of the rocket and how it shakes up the cameras that are on the drone ship, sometimes we do lose signal, or shakes up the antennas.
Oh, and we've just gotten confirmation.
We're waiting to hear what happens, and so we're listening in, and we're still waiting to hear. We'll let you know as soon as we find out. You'll know. People are cheering, but we'll get the call and know hopefully very, very soon how that Center Core is doing, whether it's standing up proud on that drone ship or not.
Meanwhile,
other two landings.
Those were absolutely gorgeous. Meanwhile, the second stage is continuing its trajectory towards Mars. It's all looking good there. John, come give us a recap of the full mission.
He stands.
Well, if you could hear all that cheering, it was an outstanding test flight of the Falcon Heavy. Cameras cycling right now. Live views coming down from low Earth orbit. The second stage successfully got there, and it got there as the culmination of a great Falcon Heavy test flight. We lit 27 engines, throttled the boosters up and down. We separated the side boosters. They came back spectacular, simultaneous landing. The Center Core did its job. The second stage did it. Everything that you could want in a test flight we got here. Now we're just looking for the icing on the cake to find out what happened on the drone show. But all in all, an outstanding test flight.